In our today's lesson, we are going to analyze bracket to column connection, and the question is, show that the bolts in the bracket to column connection below are suitable to resist the design shear force of 200 kilonewtons. Assume the bolts are all M16 grade 8.8. We have a 610 by 305 by 179 universal beam, and here we got a 457 by 191 by 82 universal beam section. The design shear force is 200 kilonewtons with an edge distance of 250 millimeters. The distance from each bolt to the next center to center are denoted. All bolts are M16, meaning that their diameters are 16 millimeters each, and they are of grade 8.8. All the bolts are 8 in number, and we are supposed to carry out the following checks. That is shear, tension, combined shear, and tension. And beginning with the shear checks, we are going first of all to check what we call the shear capacity of the bolt. So we begin with shear capacity of bolt. And shear capacity of bolt, which is denoted by PS, will be given by effective area of bolt multiplied by shear strength of bolt, whereby the effective area of a bolt is actually equal to tensile stress area of bolt, and this tensile stress area of bolt is usually obtained from table 4.22 of BS 5950, whereas the shear strength of bolt is obtained from table 4.19. And from those tables, the effective area of the bolt is 157 square millimeters. The shear strength of bolt is 375 newtons per square millimeters. We need to convert that to kilonewtons since we are going to get the answer in newtons. This one is in square millimeters, whereas the shear strength is in newtons per square millimeters. Therefore, to convert newtons to kilonewtons, we are going to divide this by 1,000, or we multiply by 10 raised to the power of -3. And when we do so, we are going to get a shear capacity of 58.9 kilonewtons. Therefore, that is the shear capacity of bolt. The shear force per bolt, shear force per bolt, is going to be given by the design shear force, which is P, divided by the number of bolts, which is 8 bolts. And therefore, shear force per bolt will be equal to the design shear force of 200. We divide this by 8 bolts. And this is going to give us 25 kilonewtons. Therefore, each bolt is being subjected to a shear force of 25 kilonewtons. Therefore, when we compare the shear capacity of bolt with the shear force that is subjected to every bolt, we find that the shear capacity is greater than the shear force subjected to every bolt, and therefore it means that under shear, the bolts are satisfactory since their capacity is greater than the force they are subjected to. Therefore, since PS, which is the shear capacity of bolt, that is 58.9 kilonewtons is greater than 25 kilonewtons, which is the shear force per bolt, which is actually denoted by Fs. So it's greater than Fs, which is 25 kilonewtons. Then it means that the bolts are satisfactory when it comes to shear. After checking shear, we are now going to check about tension. And under this, we are going to check or to calculate the tensile capacity of the bolts. So we go to tensile capacity of bolts. We are going to determine the maximum bolt tension, that is Ft, which we are going to compare with the tensile capacity of the bolt and see whether the maximum bolt tension will be greater or less than the tensile capacity of the bolt. And therefore, maximum bolt tension, that is Ft, will be given by the design shear force multiplied by the edge distance, that is E1, multiplied by Y1, that is adding the bolts spacing, which we are calling Y1. Then we are going to divide this one by 2 multiplied by the summation of Y squared. And therefore, this is going to give us P, the shear, the design shear force of bolts is, the design shear force subjected on the bolts is 200 kilonewtons multiplied by the edge distance, which is 250 millimeters. So we multiply that by 250 millimeters multiplied by Y1, which is 100 plus 100 plus 100 plus 70, which is actually 370. So we multiply that to 370. Then we divide this by twice y squared. And y squared will be the distance of each bolt from this end. The first bolt is 70 millimeters away. That is the end distance E2. Therefore, 70 squared plus the second bolt is 170 millimeters away, 70 plus 100. Therefore, that is going to be 170 squared. The third bolt is 270 millimeters away. Therefore, we add 270 squared. And the fourth bolt is 370 millimeters away from this end. Therefore, we add 370 squared. And therefore, Ft, which is the maximum bolt tension, is going to be equal to 38 kilonewtons. Therefore, that is the maximum bolt tension, Ft. Then from there, we are going to calculate the tension capacity or the tensile capacity. Therefore, we go to tension capacity of the bolts. And this tension capacity is usually denoted by P, N, or M. Whereby this tension capacity is going to be equal to 0.8 multiplied by tensile strength of the bolt multiplied by AT, which is the tensile stress area of bolt. Therefore, tension capacity will be equal to 0.8 times the tensile strength of the bolt from table 4.23 is 560 newtons per square millimeters multiplied by tensile stress area of bolt, which is 157 square millimeters. We are going to get the tension capacity in newtons. So we need to convert newtons to kilonewtons by dividing this by 1,000, or we multiply by 10 raised to the power of -3. And when we do so, this is going to give us 70.3 kilonewtons. And therefore, since the tension capacity of the bolt, that is 70.3 kilonewtons, is greater than the maximum bolt tension Ft, which is 38 kilonewtons, then under tension, our bolts are satisfactory. Therefore, since PNOM, that is tension capacity of the bolts, which is equals to 70.3 kilonewtons, 70.3 kilonewtons is greater than the maximum bolt tension, which is 38 kilonewtons, Ft, greater than Ft, which is 38 kilonewtons, then it means that under tension, our bolts are satisfactory. They are okay. After we are done with the checks on tension, we are now going to check combined shear and tension. So we go to combined shear, combined shear and tension. And tension. Combined shear and tension check. So the combined check is given by the following formula. Combined check is given by Fs divided by Ps plus Ft divided by PNOM. This one should be less than or equal to 1.4, whereby Fs is the shear force per bolt. The shear force per bolt, that is Fs. We have it as 25 kilonewtons. Ps is the shear capacity of bolt, 58.9 kilonewtons. Ft is the maximum bolt tension, which is 38 kilonewtons. And PNOM, that is the tension capacity, which is 70.3 kilonewtons. And therefore, the combined check will now be given by Fs, which is 25 kilonewtons, divided by Ps, which is 58.9 kilonewtons. We add these two, Ft, 38 kilonewtons. We divide it by PNOM, 70.3 kilonewtons. And this is going to give us 0.96. And therefore, since 0.96 is less than 1.4, then it means that, or we are going to conclude this way, hence the M16 grade 8.8, grade 8.8 bolts are satisfactory. Satisfactory. So that is how we are going to conclude. Therefore, ladies and gentlemen, thank you for watching our video. Please subscribe. Thank you.